Hey guys! Well, in my investigation of my estate and mud-flood buildings and buildings in general, I've become quite fascinated with bricks. The making of bricks, how they got them here, and the composition of bricks. It's crazy, I know, but it's where research takes you, isn't it? So, watching Martin's great video last night, Martin Leidtke, Flat Earth British, and he was looking at where some of these massive buildings in America was the granite, somehow derived from something that was a bit off. So what I've done, I've sort of been having a little look about. This is by no means meant to be like a comprehensive or conclusive study. It's just trying to establish some sort of connection between bricks, mortar, and maybe the use of bone in there, human bone, animal bone, just bone. So I found quite a few sites about bricks. I'm just putting my other glasses on, you have to excuse me. So this is a bit of a sort of like a bit of a jollily written one from the Londonist, and they talk about how, wonderful squares of Notting Hill and all this, that and the other, but they give quite a good sort of description of how London is pretty much made out of itself, its own clay. They used combustible domestic waste or soil, the ash and the cinders of the city, to provide the organic material. And they dig everything out by hand. And in a summer, a single group of labourers could produce 1 million bricks. And what they do, they put the kilns up in a field, and they'd make the bricks and sort of dig the field up, and then when they'd finish, they'd cover it all over and move on. It just sounds like a bit of a way to do it. So they've got this picture up here by George Cruikshank, 1829 sketch, London Going Out of Town, or the March of Bricks and Mortar, in which a band of robotic toolmen march on London's rural outposts, a surge of brick terraces springing up in their wake. The dome of St. Paul's peeks out from behind a barrage of new houses, while a volcanic kiln spews bricks onto hapless trees and haystacks. Now, I've actually got a better picture of it than that, this one here. This is a colour photo. So, I was interested in a couple of things in this. For a start, that's not a kiln, that's a pyramid. These are kilns. That's a kiln. That's a kiln. That's a pyramid. And chucking all these bricks out onto these haystacks. And there's lots of bits of writing which is very difficult to read. It's a slightly countryside running away from the onslaught. But these houses are wrecked. Look. They're all cracked. Cracked, and they're being held up, shored up here, cracked, and they're also built on arches, which I think is very strange. They're built up on arches, and this almost looks like water, doesn't it? Or mud flood. It's all coming in and it's all wrecking all this. And here we have these, this looks like skull and crossbones here. This is St. Paul's, and it looks like it's on fire. So everything's on fire, and there looks like a mud flood, and they're building, and this here going on. So, yeah, I thought that was a little bit of a bit of a strange one. So let's go back. That's a kiln, and there's more accounts here of people just sort of generally sort of complaining about how the countryside was being eaten up. And we got this here. This is traditional brickwork. Despite being renowned for its durability, problems in brickwork can be very serious. Blah blah blah. Brick construction in Britain dates from the Roman period. Clay was dug and allowed to weather over winter, or sometimes over several winters, until it had been broken down by frost. I mean, this is the early clay. And generally stone was being used, especially for large and high status buildings. However, after the Great Fire of London in 1666, they decided they wanted to build in brick from then on. So they built Bell Hall. Now this is quite interesting for what we're looking at. Bell Hall at Neyburn near York epitomises the growing trend for building in brick in England. Built on a stone undercroft. A stone undercroft. Okay, so an undercroft is one of these. It's traditionally a cellar or a storage room, often brick-lined and vaulted, and used for storage in buildings since medieval times. So, yeah, so one of the first brick buildings was built on a stone undercroft. And then they go back to talk about the different kilns. And I think it's down here, this one, they've got the recipe. That's nice, isn't it? Okay, right, so it's not that one. Maybe this one. Excuse me, I had it all lined up and started to do it and somebody knocked the door. So, oh yeah, this is, somebody put this up. This is about a builder, a brickie and all the brickmakers in a particular area. Thought that was quite interesting. It was quite a process. That was making handmade bricks. And then they, it's a huge kiln, Scotch kiln. There's some early brickmakers. And then they got into machine pressing, like this. Yeah. So, here we have the general sort of composition of the brick. So, silica, 55%, alumina, 30%, iron oxide, 8%, magnesium, 5%, lime, 1%, organic matter, 1%. So they don't need a lot of lime in your average brick, do you? Okay. So, silica and clay. Alumina is the main constituent cementing material. Silica, lime. It should contain a little amount of fine powdered lime, as it enables silica to melt at the furnace temperature, and iron oxide, and that's what gives it all the bricks their red colour. Yeah. Too much lime can melt the brick. They've got to burn the carbon dioxide off, I think. Okay. So bricks have got lime in them. So let's have a look at mortar. So the history of lime in mortar. The first mortars are made from mud and clay. It was discovered that limestone, when burnt and combined with water, produced a material that would harden with age. containing only lime and sand required carbon dioxide from the air. So, Joseph Aspdin, an English mason builder, patented a material called Portland cement in 1824. So here he is. This guy was a brickie, living in Leeds. He set up his own business and he experimented with cement manufacturing and worked out how to make bricks. How to make cement with a new modified recipe of cement making, the first modern cement. And this is, calls it artificial stone. And this is his patent here. My method of making a cement or artificial stone for stuccoing buildings, waterworks, cisterns, or any other purpose to which it may be applicable, and which I call Portland cement, is as follows. I take a specific quantity of limestone, such as that generally used for making or repairing roads, and I take it from the roads after it is reduced to a pebble or powder. So he scrapes it from the roads. Then he breaks it down and it tells you how he makes it. But they say here that the limestone that he used was the Pennine Carboniferous limestone, which was used for paving the streets. The characteristic practice of the patent and of his lime patent is the use of road sweepings. Road sweepings. He says if the sweepings are not available, he obtains the limestone itself. And he was twice prosecuted for digging up whole paving blocks on the local roads. Limestone supply was clearly a major headache for him. Okay. So I got to thinking, what else do they make? What do they use bone for? I was thinking about bone meal. Then I remembered bone china. So I had a look at ceramics. Yeah. Bone ash makes up about 50% by weight of fine bone china. Typical analysis for calcined bone is 67 to 85% calcium phosphate, 3 to 10% calcium carbonate, and small amounts of CaO and CaF2. So CaO is lime, quicklime, yeah? So I did a little bit more digging about, and I found this question. Is there any truth to the idea I've heard that the ancient Romans used bone or bone meal in making concrete? And somebody says, no, there wasn't enough to make the abundance of concrete the Romans used in all their building. Blah, blah, blah. And then this guy pops up. David Wilmshurst, Technical Manager, Materials Consultancy and Lab. Okay. So he said, is there any truth to the idea I've heard that the ancient Romans used bone or bone meal in making concrete? Absolutely possible, despite what my kids would have you believe. However, I wasn't there, so cannot act as a witness. Calcined bone is typically 55 or so % CaO, aka quicklime. The rest is largely phosphorus pentoxide. Strangely not, bones etc. are where limestone came from. Okay, interesting. So what have I got here? Ah yeah, the scientists discovered the secret recipe of Roman concrete. So their secret recipe was volcanic sand. That's what they found. Volcanic sand and lumps of volcanic rock, so they ground it down. But they still had lime in there. Everybody has lime. Lime's still in there. And then I found this. This is great. The influence of CaO and P2O5 on bone ash upon the reactivity and burnability of cement raw mixtures. So, the introduction. The main concerns of cement industry and cement researchers are and will remain the energy savings, environmental protection and pollution control. To achieve these goals, cement industry and relative sectors are developing constantly the concept of use of alternative fuels and raw materials in the production of clinkers and final cements, So clinkers is the product that's there when you fired it, like small pebbly things. So give it all a little bit down here, and then he says, one of these alternative fuels that could be considered as alternative raw materials are the meat bone meal, referred as meal bone meat, MBM, or other processed veterinary wastes of animal origin. The cement rotary kiln reaches high temperature needed to effect degradation of biological wastes. The ash of the meat bone meal is composed mostly of P2O5, that's your phosphorus thing, and CaO, which is mostly in the form of calcium phosphate. So there's your lime. So then they give you a lot of information about the study, how they had it done into 2 or 3 different groups, fired at different temperatures. The aim of the present investigation is to show that the bone meal can be utilised, not only as alternative fuel, but also as a source of material, alternative material. The ash of bone meal contains CaO, so it can be used as partial substitution of limestone. The calculation of CaO fraction from the ash of bone meal into the total CaO account balance in the cement raw meal will enable to combust higher amount of the bone meal to reduce the CO2 emission and to save one of the basic raw material in production of cement, limestone. So yeah, these guys are saying that you can make limestone or lime out of bone. So the Romans, now this is where it really starts to dovetail into what I'm looking at as well. Ancient Roman burial practices. So the Romans were obsessed with death, because I've been looking up ancient guilds which seem to go back to the Roman collegiate, and they were obsessed with death. They had burial clubs. Unbelievable. So Romans could bury or burn their dead, practices known as inhumation, burial, and cremation, burning. But at certain times one practice was preferred over another, and family traditions might resist current fashions. So in the last 100 years of the Republic, cremation was the most common. Yeah. So they were burning their dead. They had a terror of death. And they had these special places. Hang on, let me see if they mention it here. It's all about burials, and this is where we burial outside the city limits. Here we are. So we had Collegia Funeratitia, funeral societies, columbaria, resting places for the ashes of members of the collegia. They were absolutely, completely obsessed with death. And who does that remind you of? So this little report here says that yeah, you can get lime from bone to be used in mortar and to be used in bricks. And our friend here, Joseph Aspdin, grovelling around to try and find lime to put in his cement and scraping it off the pavement. I wonder where else he was getting it from. They're not going to tell us, are they? They're not going to say, oh yeah, well, they used bone. All the dead people, they burnt them up in the burn pit and used the ash. So there is some sort of evidence of a kind to show that that's what they were using. And the Romans were using volcanic ash, lime, in their mortar. So Who's to say, eh? Anyway, I just thought I'd sort of like try and sort of like make some sort of connection between bone, brick and mortar, and save people a bit of time, and maybe this could be a starting point for something for you. Anyway, thanks for watching. I'm sorry it's all been a bit bitty, but I have to narrate separately from the video and it's awkward.